Okay, today we are going to learn about sound wave. What is sound and what is wave? Okay, what is sound? Sound is caused because of the vibration. Okay, sound is caused because of the vibration. Wave, what is wave? Wave is a form of energy. So the vibrations causes energy. So the energy happens and it will vibrate the molecules of the air, and the molecules of the air will push another molecules of the air and will send the message in the form of sound to our ear so that we can hear what people say. Okay, so what makes people hear the sound? There are three things that we have to know why people hear the sound, or there are three requirements why we hear the sound. The first is there is vibration. There is vibration. So when there is no vibration, there will no sound, because sound is caused, sound is produced by the vibration. Sound is produced by the vibration. Okay, without vibration, there will no sound. Okay. Number two, three requirements. This why we can hear the sound is because there is media or medium, like air. Without air, we cannot hear what you say. The sound wave cannot propagate. The sound wave cannot be transferred in the space, in the area, in the area there is no air inside. Okay, and number three is because there is ear to hear. So three things why we can hear. Why we can hear sound. Okay, so now after we know the requirements or why we can hear the sound, now we have to know the first cases of sounds, which is very common, which is frequency. So what is frequency? What is frequency? Frequency is number of oscillation per second. So frequency is number of oscillation per second or per time. Okay, so the number of oscillation per second. The sound wave. Okay, I will draw the air molecules. The air molecules. This is dense air molecules. When the vibrations come to the molecules, when the vibration comes to the molecules, and these molecules will push another molecules, and there will be force inside of the molecules that push another molecules, the neighbor of the molecules. Okay. So this is rare space, this is dense space, and this is rare space, and this is dense space, or rarefaction, contraction, rarefaction, and contraction happened when the vibrations or when the sound is transferred through the air. That will be rarefaction, and this one is called contraction. So rarefaction and contraction will happen during the transfer of the sound wave. Okay? So the frequency is a number of oscillation per second. What does it mean? What does it mean, the number of oscillation per second? So when you get this graph, so you will be asked which one is the frequency. So the frequency is the number of oscillation per second. Told you that the frequency is the number of oscillation per second, which is one oscillation is from A to B, okay, through this point A to point B. This is one oscillation, okay, or one wavelength. So one wavelength is A to B. So the number of wavelength, the number of oscillation per second is frequency. Okay? So now what is period? The period is the time taken for one oscillation. So what is the time you needed to travel from A to B is called one period. Okay, the period is the time taken per one oscillation. So now let we compare the frequency, the larger frequency and the smaller frequency. What are the difference? First, I will tell you that the larger frequency here and smaller frequency. The difference are the larger frequency, it has very small space. Okay, it is the characteristic of the larger frequency. But what is the characteristic of the smaller frequency? The characteristic of the smaller frequency is, okay, let me compare that this the amplitude or the highest the same, okay, but it has larger frequency. Okay, imagine that the amplitude are the same. So this is smaller frequency, larger frequency. Smaller frequency has smaller wavelength. Larger frequency has smaller wavelength. While smaller frequency has larger. I told you this is larger. What I mean larger is the distance between point A to point B is further or is larger. For example, 2 meters, but this one is only from point A to point B, maybe 30 centimeters or 0.3 meters. Okay, has a larger length. So this is the difference between larger frequency and smaller frequency. Okay, the second. How about the period? About the larger amplitude and smaller amplitude. The difference is between the highest point of the wave. Okay, so this is what we call by amplitude. The distance between the equilibrium position to the highest point, let's say point A. Okay, but the smaller amplitude is maybe like this. Okay, it has only very short distance, point A for example. Okay, so we compare this distance to this distance. This distance has larger distance. Okay, it means that it has larger amplitude, but distance has smaller amplitude. Okay, so what is the relation between frequency and amplitude? Okay, so what is the relationship between frequency and period? That the frequency is equal of 1 over period. So what we say that in daily life, larger frequency and smaller frequency. The smaller frequency is the same with small pitch. So frequency is the same with pitch, large pitch,